Hey guys, so on to question 3. Queue data is a queue that stores up to 20 string values. The queue has a start pointer to identify the first element of the queue and an end pointer to identify the last element of the queue. Write a program that defines queue data and its pointers. Okay, so this is going to be similar to last time, where I'm not totally sure how I'm going to do queue data, but normally if I'm doing an abstract data type, it makes sense to do it with stuff inside of it, rather than just leaving an empty array, but up to you. So anyway, I'm going to have queue data, and that's going to be a blank array. Now what size does it say? It says 20 string values. Okay, so I could do none times 20, or I could possibly do like a blank space times 20. I prefer none. My concern is always that I need to let them know that it is a string array. Again, you probably want to type it out just in the full way that you've done before. If you've done paper 2 and 3, you shouldn't have any issues with declaring, apart from me and my spelling, declaring in pseudocode. So declare queue data, and that's going to be an array, and it's going to be of size, in my case, it's going to be 0 to 19. And it's going to be, I think it said, of string. Okay, so that should be clear enough for anybody to get our queue data. And then we're going to have to declare some pointers. So as a start pointer, to identify the first element. So let's get start pointer and an end pointer. Okay, so start pointer. Now I'm going to set the start pointer to be -1 because there's nothing in the array. And then the end pointer is going to be the next space where I'm going to add the element. Okay, so I'm going to set that to 0 to begin with because it's going to start at the beginning of the array. Now, again, I'm going to have to declare these. They may change. So I'm going to start with it this way. That's kind of like my default go-to way when doing a queue and its pointers. But if they start doing funny stuff, I might want to change them around later. So anyway, I'm going to declare start pointer and end pointer, and I'm going to set them to be integers. Integer. Okay, so I've declared and initialized all of those things. Okay, let's see what else we got. Start pointer and end pointer. Blah. Good. Tick. A done. So write a program. Write program code, for a function enqueue. The queue should take the item to be added as a parameter. If it was successfully added to the queue, the function should return true. If the queue is full, then it should return false. Each time it should update the pointers. Again, you can do this however you like. My dog's going crazy. Might need to pause for a second. I can put these into here. Now it's going to be a function, so it's going to go at the top here. And then I can just comment it out. And I'm going to have to go shout at my doggy. Just give me 1 second. Okay, sorry about that. Puppy. Anyway, okay, so we've to make a function. The function should take the item to be added to the queue as a parameter. So I'm going to do def. Does it give me the name? Oh, yes, it n queue. And it's going to take the data as a parameter. And I can leave in your comments if you like. Okay, if it's going to return true, otherwise it's not. So, and then update the pointers. So what we want to do when we enqueue is we want to check if the queue is already full. Okay, so that would be if the Now, we're going to have to work ahead a bit probably, but that's probably going to be if some of this other stuff is. So if the start pointer got to 19, for example, then it would be full. So let's check and see if it's full. Okay, now, as I've said before, what I would always do, where I can, is I would maybe try and draw some of this out as a doc or something, okay? Okay, so I'm going to have a table, and let's have, what did it say, 19 elements, right? Okay, so I'm going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oops, and I need one more. 19. Okay, so that's going to be 20 elements. And then my head pointer is going to be equal to -1 to begin with. Okay, so that means whenever I add an item, basically that means the queue is empty, okay, if it's -1. And then my rear pointer, or end pointer I think it was called there, is going to start at 0, and basically to add that's the space that I'm going to add the next item in the Q2. So if I enqueue, I'm going to use the end pointer to point to that location. So in the situation where, so it should already be pointing at the next location at the start. So in the situation where it is when it is greater than 19, so it should be pointing at location 20. So if the end ever becomes equal to 20, then I know that my queue is full. Okay. Okay, anyway, we'll play around with it. We just need to start with what information we have and build it up. You could read ahead if you get time, but that's just going to depend on you and the exams and stuff. All right, so enqueue. Now, in order to bring this information into here, I could either do it as globals or I could pass it as parameters. Normally I prefer parameters, but I'm going to do global just to show you that we can. So I'm going to do global end pointer. And then, so if the queue is full, should return false. So I'm going to say if end pointer is greater than 19. I could put equals 20. I just feel like this gives me a bit more safety if there's something I've not figured out. Then, if the queue is full, then the function should return false. Okay, now it doesn't say we have to display an. If the queue is full, it should return false. Okay, now it doesn't say we have to return any information, so that's fine. If the element was successfully added to the queue, then it's going to return true. Okay, so then we're going to have our else. So in that case, we're going to say that, and I'm going to need a global queue data as well. And again, I could do those parameters. It doesn't specify, so we should get marks either way. So if the end pointer is greater than 19, return false. Otherwise, the queue data at position end pointer is going to become equal to the data. And then we're going to return, we need to update our end pointer. So end pointer is going to equal the end pointer plus 1. And then we want to return true. It should return true. Okay, each item set by the function should update the pointers. Okay, cool. So that should be our enqueue situation, I hope. Now, you might want to test this a little bit, so it's always good to throw some data in and figure out there's issues now, then figure out there's issues at a later date. So if I were to enqueue, and I said I'm enqueuing a string, so I'm going to enqueue A, and then enqueue B, sorry, that should be in quotation marks. Now, were I to print my array, bearing in mind that enqueue is going at 0 and then 1, so for x in range, let's do from the length of q data down to 0. And we're going to do -1. Okay, and then we're going to print q data, square brackets, x. Okay, now we don't need this. This is just my test. This has not been asked for yet. I just want to see if my queue is working. So I should have A and B. Oops, index out of range. Print q data x. So we're going to go from the length of the q data -1. And then that's going to be from 0. Let's try that and see. Okay, no, B. So that should be till -1, I believe. Sorry, because it's not inclusive. Okay, so this is what my current queue looks like. A is at the front, and B is second, and so on. Now, one thing I have forgotten is I've forgotten to update the start pointer. Because at the beginning, I'm using -1 to denote that the queue is empty. Okay, so if the end pointer is greater than 19, then we return false. Now, inside this else here, so if I'm adding something to the queue, then I'm going to say if the start pointer is equal to -1, then the start pointer is going to become equal to 0. Okay, so that's us adding it to the first existing space in the array, should we need to. Alrighty. Okay, well, let's try that again. Check there's no errors. A, B. Okay, and our head pointer should now be pointing at 0. If I go back to that document, my head should now be pointing at 0. And I've got A, and then B, and my end pointer should be pointing at 2. Okay, so pointing at 2, which is the next space, and 0 is pointing at the start of the queue. Okay, let's go from there then. So, what else have we got? Okay, write the program code for a function, read file, which asks the user to input a file name, reads the data from that text file into q data. Okay, the function returns the following values. All the data successfully read into the queue returns 2. If the queue is full and the data could not be inserted into the queue, it returns 1. If the text file could not be found, it returns the value -1. Alright, so, I mean, that's easy enough. Again, I'm going to copy it in just so I can work at my program at the same time. I'll delete it after. So we're going to have another function called read file. Okay, so I'm going to def read file. Okay, ask the user to input a file name. Okay, so we can say file name. Again, they seem to use capital stuff, but it should be okay either way as long as we're consistent, but let's just follow their rules. We can say enter the file name to read from. Okay, done. Okay, reads the data from the text file into q data. Okay, so that's going to be using our enqueue function. Okay, so reads the data from the text file. Okay, now we'll come to that into QData part second. So how do we open our file? Well, first of all, we've got to use our try and accept. Okay, so we want to say try first, and then I'm going to say call it be like in file equals open, and then I'm going to include the file name that they've typed, and I'm going to open it for read. Yeah, and then I can do for line in file. Well, I'm going to do some stuff there. Oops, I'm going to pass for now. And then if for some reason I can't read the file, I'm going to have an exception. Now there's different types of exceptions. You can deal with that yourself as you like. However, I think IO exception. I need to double check. I can't remember. If I can't remember, I just use except. And then what does it tell me? So if the text file could not be found, the function is going to return -1. Okay, so I can get rid of that. 9. Okay, so in file equals for line and in file. Well, what am I going to do for line and in file? I am going to add it to QData. Okay, so for line and in file, and I'm going to need QData. So let's do global QData. Do I need to? No, I don't, because I've already got enqueue here, so I don't actually need QData yet. So what I'm going to do is I'm going to enqueue the line. Okay, now here we have to be careful. So I'm going to need another little variable, and let's call it result. And I'm going to set my result to be if all the data is incepted, then it's going to return 2. So my result is going to start at 2. Now, if I can't find the file, then I'm going to change the result to be -1 for can't find file. Okay, I believe so. Let's check that. -1 if you can't find the file. If we try to read it in and we enqueue it, now we're going to have a full, or let's call it not full, and that's going to start as true. Now here, this is going to return false if it's, so it's going to return true if successful. So it's not full is true. Yay. But whereas if it's false, that means it's going to do something else. Okay, so I can have not full is going to equal the enqueue line. So if we try to enqueue a line, and for some reason it doesn't work, then it's going to return false. So that's only if the thing is full. Otherwise, it's going to return true. Now, yeah, okay. So, okay. So now for line and then what I want to do is, if it's all been successful, that's okay. Oh, and then I need to remember to in file dot close. I need to remember to close my file. We often get marks for that, so just it's worth putting in. I often forget it. I'm a bit stupid that way, but it's what it is. Okay, so basically read in the file for each line, try and enqueue it. If for some reason you can't, not full is going to be equal to false. Okay, and then at the end here, I can say if not full still. So if we've had return values and it's not full, that means we've been successful. So if we've been successful, then we're returning a value 2. So then result is still 2. So if not full, then we're going to set not full. Sorry, we're going to set result to be, I think it's a 1, right? So if the queue is full, then it's going to return a 1. Okay, so result is 1. And then at the very end of our program, we just have to return the result. Okay, so let's run through. What have I done there? So I've asked him to enter the name of the file. I've said set the result to true. So by default, we're saying everything is fine. If it's not full, then we'll keep that as true. So this is to say it's not full. Then we're going to try the following. We're going to try and open the file, and then for each line in the file, we're going to try and enqueue it. So if the enqueue is successful, not full will continue to be true. If it's not successful, then enqueue will become false. So if it is not full, then we're going to set that value to be 1. And then we're going to remember to close our file. If it cannot read the file, then we're going to get result -1. And then at the end, we're going to print the result. Okay, so let's try that and see. I can get rid of that now. Don't need my test. So I'm going to read file. I don't need these enqueue bits because I've used them already. So when I read the file, now what I'm going to do is I'm going to print the output of read file. Okay, so one thing to notice is that I've got data to add.txt and second data to add.txt as files that should work with read file. So let's see if they do or not. Oops, what have I done? Oh, I've left that whole thing in. That was stupid. Let's try again. Let's make it nice and tidier to read. Okay, so let's say I went for a file that doesn't exist. -1. So -1 means the file could not be found. Yay! Okay, so then what if I were to add the data to the queue? So data to add, I'm wondering how many things are in here. Okay, so that should be enough for us to add without getting an error. So this time, if I run it, it's called, I think it's called first data.txt. Oh, -1, that's not good. So first data.txt, whereas the file, it's called data to add. Where did I get first name? Let's try again. Data to add. Oh, data to add.txt. See, I'm getting flustered. Data to add.txt. -1? Why? Okay, so for file name equals input, the file to be read from, results to not full. So try in file equals open, the file name for read. Okay, now what I'm going to do is I'm just going to highlight these out for now because I think this might be causing the issue. So let's do that there. Okay, now we might need to do the rest of it afterwards and see. File to read from, data to add.txt. 2. Okay, so that's working. Then for line and in file, not full equals enqueue the line. Okay, so for line and in file, not full equals enqueue line. Okay, now which of those is causing the issues? Data to add.txt. Okay, so there's something wrong with this line here. So for line, capital, in fine. Okay, now let's try it. Yay! Okay, so I had an error here, and this is one of the issues with the try and accept. It was basically because I hadn't specified an IO error, what it did was any error would have been a -1 result. Okay, so now hopefully, if I tidy it all up and run it, then I'm going to read from the data. Oh no, I'm still getting a -1. Okay, so if not full, result equals 1 for line in file, enqueue line. And I've done the same mistake there. Let's try again. Yay! Okay, so, and this is just me having a hangover from the general Python rules. So normal Python rules says that variables should be lowercase with a underscore between it. But because of the way the exams are set up, they want it camel case, which is the first letter capital, next letter capital. So just be careful of your own habits in that sense. And don't be afraid to sit and debug stuff. Remember, you've got the debugging tools as part of your IDE as well. Anyway, I think that's right. So I bet it's going to ask me to do exactly what I just did, but let's check. Anyway, so I've done this, and now the main program calls read file, and outputs an appropriate message to identify if the text file could not be found, the queue is full, all items were added to the queue. Okay, edit the main program to call read file and output message. So it's very similar to what I've just done. So I said we were going to read the file, and then we were, so we're going to ask the user to enter the file to read from, and then in our main, we are going to call read file, and I'm going to get something in there that holds the result. Let's call it read result equals the read file. So whatever the return value is, read result is going to come equal to that. And then I can do if read result is equal to, now -1, I believe is file not found. Print, sorry, file not found. Now, does it give us a specific error? Does it just say give an error? Okay, I mean, I could use these exactly. I think we'll still get the marks if it's not exactly that. But for safety's sake, I could say the text file cannot be found. Otherwise, if read result is equal to 1, that means the array was full, or the queue was full, sorry. So if it's equal to 1, then I'm going to print the queue was full. Again, that should be totally fine. And then, basically, in any other situation, I want to say that the, I shouldn't have deleted that, that was stupid. All items were added to the queue. All items were added to the queue. Okay, and so I think that's what it's asking for. Now again, I could run it and check. I suspect they're going to ask us to run it and check anyway. So let's go ahead and see what they're asking for. So you have 2 text files, data to add and second data. Use the file names below as your input to the text program. Data to add, third data, and txt. Now take screenshots of all of these situations. So let's see what's second data. Okay, so I think second data is probably going to be too big. Data to add should be fine, and then the third one should be file not found. Okay, so let's give it a go. So save and run. Enter the file to read from. Well, we start with data to add.txt, which should be all good. Yay! Okay, now what if we were to do the other file, secondData.txt? Check there's no space in front of that. Ah, the queue is full, as expected. So screenshot, put it into my thing. And then the last one was just a non-existent file. So I think it said third data, something like that. The text file could not be found. Yay! So that has been successful. And I take those screenshots and I put them into my evidence doc. Done, done, done. And we're almost there. One more question. Okay, so the function remove removes the first two elements from the queue, concatenates, so joins the elements with a space between them. For example, if the first word is hello and the second word is world, the hello world, okay, returns the concatenated string, returns no items if there are insufficient items in the queue. All right. Not sure what the purpose in this is, but we don't need to think about that too much. We just need to do what we're asked to do. So we're going to define remove. Bracket, bracket. Now I'm going to post my stuff here. So the function remove removes the first two elements from the queue. So we're going to have to dequeue. Okay. So I just want to double check. I don't have a dequeue method, I believe. No, I've only created the enqueue method. That's fine. I'm just wondering if I should have a dequeue method, but I don't. So this remove function is effectively going to be a dequeue. Okay, and then it's going to concatenate. So again, let's do it in a verbose way or a long-handed way. Now we're going to need to have our pointers. So let's bring our pointers in to the remove function. Method, procedure, not sure. Anyway, we're going to have our stuff coming in. So we'll get our queue, start pointer, end pointer. And then we're going to remove the first two elements from the queue. So we're going to have element 1 equals strings, I believe. So we can do string and element 2. And that's also going to be a string. String. Okay, so removes the first two elements from the queue. So we can say that element 1 is going to equal. Now, when we do a queue, we're going to go from the head. Okay, so we're going to take the head pointer and add one to the head. And we're going to use the head again and add one to the head. Okay, so let's try that. So the element 1 becomes equal to the queue data. Sorry, not head, that the start pointer. And then we're going to do start pointer equals start pointer plus 1. And then I'm going to do exactly the same thing for the second element. Okay, now what I do need to check before I figure that out is I am going to have to work out if there are enough items in the queue. Okay, so how would I know there are enough items in the queue? Well, at the moment, I've got my end pointer pointing to here, and I've got my head pointer pointing to here. So if I were to dequeue this and add 1, dequeue and add 1, then whenever I check it, it should already be at this space. So basically, if the head pointer is equal to, greater than or equal to the end pointer, then we know the queue is full. Okay, so I can do if, sorry, I keep calling it head pointer, start pointer, is greater than or equal to the end pointer, well then I know that the queue has a problem. Okay, so if it's Okay, so it returns no items if there's insufficient. Okay, so I can do return no items. Okay, okay. Otherwise, I'm going to set element 1, and I'm going to add 1 to the start pointer. Okay, now I could probably do a loop here to make this nicer, because I'm going to do exactly the same thing again, but I'm just going to be lazy today and just have it as 2 different things with element 2. Okay, so again, if the start pointer is greater than the end pointer, return no items. What's the other situation? Well, the other situation would be if the queue is empty at the start. So I could also say, or the start pointer is equal to -1. Because remember we said that start pointer equal to -1 is going to be a empty queue as well. Okay, so hopefully I take that there. And so I've got 2 situations. Either we've got to the end pointer or the start pointer is -1, in which case we return no items. Else we da-da-da. Now remember, a return will end our function, so we don't have to worry about what comes after this point. Yeah, what comes down here is only going to happen in our else statements, assuming there are the else statements. So it tells us that concatenates the thing and returns the concatenated string. So let's call it concatenated. Is then going to equal the element 1 plus a blank space plus element 2. Okay, and we are then going to return concatenated. Now again, we maybe want to declare things to make it better than mine. You can do if you like. Okay, now it doesn't actually use us. It doesn't actually say that we should test it in any way. And we're at the end of the test, so that should be the end of the exam, but I want to check my stuff. I want to see if it's working or not. So the one that I know that it's working is the... So I know that this is working already, okay, for data to add. And then at the end there, I'm going to... Sorry, my dog needs some attention. I'll wait 1 second. Okay, sorry, wee boy needed some water. Where was I? Okay, so we've returned concatenated, and so down here, I am then going to call remove, and that should take the first 2 items off the array, and then I'm going to print their removed concatenated items. Okay, maybe it don't work, maybe it does. Let's find out. And this is why I like Big Before. I've said it like a million times now, but I like being able to run stuff and see if it goes good or bad. And it was data to add.txt. All items were added to the queue, and we get green, red. That's not right. Okay, so what went wrong there? Okay, so minor issue, I think. I think when I read in the data from the file, I want to take the line, but I don't want to enqueue the line, I want to enqueue the line dot strip. So the reason I'm getting what I'm getting there is because there are things like new line characters that I'm appending to my queue. And we don't want those extra characters to be there. And I believe if I run it this time and I do the data, oh sorry, data, I almost did the wrong thing again. Typical me. Okay, and this time green space red. Yay! Okay, and let's check if we did it again. It should do a different set of data. and data to add.txt. Yay, purple, blue. Now what if we did a bunch of them, just to check that our error message works as corrected? No items, no items, no items. Okay, perfect. Yay, so this is working as I hoped. And then I'm going to get rid of that because that's not actually asked for, but it's good to test out your stuff, show yourself that it works, and then you can walk out of the exam just feeling happy and comfy. Alrighty, any questions or anything you want me to go over, please let me know.